Oh, so get this. We're diving into some AI research today,
Yeah.
and it's going to make you rethink what AI can do.
Oh, yeah.
Yeah, we're talking LLMs, those large language models.
Sure.
But not just any LLMs. No, no. These are showing, like, actual signs of reasoning.
Whoa.
It's pretty wild. DeepSeek, the company behind this, presented their findings at AME 2024. And let me tell you, the results are wild.
Really?
Yeah. We've got excerpts from their research paper and even a chart comparing DeepSeek's new model, DeepSeek R1, to some of the big names out there.
Okay, I'm intrigued. So what we're hoping to uncover today.
Well, I want to understand how DeepSeek used this thing called reinforcement learning to make their LLMs better at reasoning. Like, what worked, what didn't work, and what it could mean for the future of AI, as a whole.
It's exciting stuff, for sure. For a long time, true reasoning seemed to be like the holy grail of AI.
Right.
LLMs were great at, mimicking human language, writing poems, translating stuff, even generating code.
Yeah?
But when it came to tasks that needed logical deduction or problem solving.
And just couldn't quite get there.
Exactly.
Yeah, it's like they could follow instructions, but not think for themselves.
Exactly. But DeepSeek's research is suggesting that might be changing.
Interesting. And they started with this model called DeepSeek R1, which had this, like, incredible aha moment.
Right.
What happened there?
So their initial approach was to train an LLM using only reinforcement learning.
Okay.
No pre-existing data, no hand-holding, just letting the model learn by trial and error. And that's where the aha moment came in. In the research paper, there's this anecdote about DeepSeek R1 trying to solve a complex math problem.
Let's hear it.
So the model was working through the steps, and then right in the middle of its calculations, it generates this output. Wait, that's an aha moment I can flag here. Let's reevaluate this step by step.
Whoa, hold on. It's like
Yeah.
it realized it was going down the wrong path and decided to, like, pause and rethink. It's almost like self-reflection.
It is quite remarkable, and that behavior wasn't programmed. It emerged organically through the reinforcement learning process.
So it wasn't the developers teaching the model to do this. The model learned it on its own.
Yeah.
That's a pretty big deal.
It is. This suggests that reinforcement learning could be a key to unlocking a deeper level of reasoning in AI systems.
Wow.
DeepSeek R1 was a proof of concept, but it had its limitations. The output could be messy, hard to understand, so they built on that foundation to create DeepSeek R1.
So they took this raw potential from R1 and kind of refined it.
Exactly. They used a 4-stage process. First, they gave the model a small amount of well-structured data to get it started.
Okay.
Then they incorporated reinforcement learning, but this time focused specifically on reasoning tasks, rewarding the model for developing clear, logical thought processes.
So it's not just about getting the right answer. It's about getting there in a way that makes sense.
Precisely. The third stage involved collecting data from the model's performance and fine-tuning its abilities,
Okay.
focusing on readability and making sure it could communicate its reasoning clearly.
So making sure it can explain its thinking process in a way that humans can understand.
Right. And finally, they applied reinforcement learning to a wider range of scenarios to make sure the model could handle different types of challenges, not just reasoning tasks.
Gotcha. So they basically took this untamed reasoning ability and gave it structure and guidance to create a powerful and versatile model.
A very good way to put it.
Okay, so we've got this new model, DeepSeek R1, that's supposed to be a reasoning powerhouse.
Yeah.
But how does it actually stack up against the competition?
Well, the results are pretty impressive.
Yeah.
We have this chart, figure 1, from the research paper, which compares DeepSeek R1 to some of the leading models like OpenAI's O1 1217 on various benchmarks. And DeepSeek R1 is either on par with or even beating these models in some cases.
Wow, okay. Let's get into some specifics. What kind of benchmarks are we talking about?
Well, they tested it on ALE, the American Invitational Mathematics Examination. DeepSeek R1 achieved a 79.8% pass rate. Actually slightly better than OpenAI's O1 1217.
Beating a model from OpenAI, that's a big deal.
It is.
Well,
On another challenging math benchmark, Math 500, DeepSeek R1 got a 97.3%.
wow.
Essentially a perfect score.
Okay.
And it's not just math. It achieved a very high ranking on Codeforces, a platform for competitive coding, putting it in the top 96.3% of human participants.
So it's not just writing code. It's writing code that could win competitions against humans.
That's right.
It's amazing.
Yeah.
But is it just a math and coding whiz? What about other areas of knowledge?
It also performed exceptionally well on the MMLU benchmark, which tests, general knowledge across 57 different subjects.
Hmm.
This indicates that its reasoning ability isn't limited to, just math and code. It can apply that same logical thinking to a wide range of topics.
This is pretty mind-blowing stuff. We're
Right.
talking about an AI that can solve complex math problems, write winning code, and answer your trivia questions.
And it doesn't stop there.
There's more.
There is. DeepSeek also wanted to explore how this reasoning ability would translate to smaller, more accessible models.
Right, because most people don't have access to the kind of computing power needed to run these giant models.
Exactly. So they used a technique called knowledge distillation to transfer the knowledge from the massive DeepSeek R1 model to smaller models.
Okay, this knowledge distillation, how does that work?
Think of it like having a brilliant professor teaching a group of students.
Okay.
The students learn from the professor's expertise and develop their own understanding of the subject. In this case, the smaller models were trained on data generated by the larger DeepSeek R1 model, essentially learning from its reasoning patterns.
So they're learning from the best, absorbing that reasoning ability from the master model.
Yeah.
And what were the results? Could these smaller models keep up?
The results were surprising, to say the least. The smaller models, even with way fewer parameters, they demonstrated some pretty impressive reasoning capabilities.
Really?
Yeah, the 7 billion parameter model actually outperformed GPT-4 on some tasks.
Wow.
And the 32 billion parameter model was right up there with O1 Mini.
Hold on. So you're telling me a model like a fraction of the size is outperforming some of the most advanced LLMs out there?
Yep.
What does that even tell us about building smarter AI?
It suggests that the size of the model might not be the only factor, determining intelligence. The way a model is trained, specifically this knowledge distillation process, seems to play a critical role.
So it's about transferring those reasoning patterns, those efficient ways of thinking to smaller models.
Exactly.
That opens up a lot of possibilities, doesn't it?
Yeah,
Makes this kind of advanced AI more accessible.
absolutely. This could democratize access to powerful AI tools, enabling more people to benefit from this technology.
And speaking of benefits, let's talk about real-world applications. Where do you see this kind of reasoning AI having the biggest impact?
One area that comes to mind is scientific research. Imagine AI systems that can not only analyze data, but also generate hypotheses, design experiments, and even discover new scientific principles.
That would be a total game changer for fields like medicine, material science,
Yeah.
climate change research. I mean, the possibilities are kind of endless.
And think about the potential in education. AI tutors could provide personalized instruction, adapting to each student's individual learning style and pace.
It would be like having a personal tutor that truly understands your strengths and weaknesses, guiding you through complex concepts, helping you master new skills.
And in healthcare, reasoning AI could help doctors diagnose diseases earlier, develop personalized treatment plans, and even predict potential health risks based on, individual patient data.
We're talking about potentially saving lives and improving the quality of life for millions of people.
Right.
It's almost like we're giving these AI systems the tools to think like humans,
Yeah.
to approach problems with logic and creativity, to come up with solutions we might never have even imagined.
That's a very apt analogy.
There's one more aspect of this research that I found particularly interesting: DeepSeek's willingness to share their failures. They talk about two approaches that didn't work: process reward models and Monte Carlo tree search.
Transparency is crucial in scientific progress. Understanding what doesn't work is just as important as understanding what does. It helps us refine our approaches and move forward more effectively.
So tell me about these failed attempts. What were they trying to achieve, and why does they work?
Well, with process reward models, they were trying to give the model feedback not only on the final answer, but on each step of its reasoning process. The challenge was that it was very difficult to define what constituted a good step. And model ended up trying to game the system rather than truly learning to reason.
So it's like a student figuring out how to get a good grade without actually understanding the material.
Precisely. And with Monte Carlo tree search, they were trying to break down the problem into smaller parts and have the model explore different solution paths.
Like a choose your own adventure for AI.
Yes, but the search space for language is vast,
Yeah.
almost infinite. The model would get lost in all the possibilities and couldn't learn effectively.
So these failures, while initially disappointing, ultimately help them refine their approach and arrive at this breakthrough with DeepSeek R1. It's a good reminder that progress is rarely a straight line. It's a journey of exploration, experimentation, and learning from both successes and failures.
Absolutely. And by sharing both their successes and failures, uh, DeepSeek is contributing to the collective knowledge and advancement of the field of AI.
Right, we've covered a lot of ground in this deep dive. We've talked about how DeepSeek unlocked reasoning in LLMs, how their model performs against the competition. And we even touched on the potential applications and the importance of responsible development.
It's been a fascinating discussion.